Those who are in the know that when it comes to measuring the performance of a graphics card, FPS is just part of the story. I mean, you could have all the FPS in the world, but if you had an extremely high latency from your mouse click to the graphics card processing it, outputting it, and actually seeing the photons hit your eyeballs, that wouldn't make for a very good gaming experience. Furthermore, efficiency matters. If you had two graphics cards that performed the same, but one of them sucked back 500 watts and output so much heat in your room that you're like, gaming like this, well, surely you'd rather have the more efficient one. Now, we've tried a variety of different methods of measuring these things in the past, everything from clamp meters for power to makey-makeys with high-speed cameras for input latency, and sometimes it actually worked out okay. But more often than not, it required more setup than we can put into every single GPU on every single test bench. Fortunately, that all changes today. Meet Nvidia's homegrown tools. They're calling these the LDAT and the PCAT. And we're gonna see A, if they work, and B, we're gonna discuss whether or not you can trust them. GlassWire is the tool that shows you which apps are slowing down your connection in real time. It's used by security pros to monitor for malware, block bandwidth wasters, and detect suspicious activity. Get 25% off using offer code Linus at the link below. Let's start with LDAT, the Latency and Display Analysis tool. It's a rather unassuming looking Logitech G203 Prodigy. But wait, you need to look closely. There's actually a second wire coming out of this thing. And if we follow it down to the end, we find, wha-bam! A photo sensor. It's embedded in an unassuming looking little 3D printed housing, and that wire from the mouse plugs right into the front of it, a little something like that. So then, how is this supposed to work? Like so. When you place this puppy on the screen, it detects changes in light output. So that means we're actually using a similar method to something like the one made by Leo Bodnar, but fundamentally different in two ways. One, instead of taking an HDMI input to measure display latency, we are actually taking a mouse input to measure end-to-end mouse to photon latency. Two, it's software controlled from back to front. So through that, we can set up an auto fire mode that is completely unattended. As long as something on screen changes every time the mouse clicks, we can repeat our tests indefinitely to get a reading of potentially hundreds or even thousands of data points within a single minute of testing, giving us an extremely accurate result. It even lets us see raw sensor data so we can determine where the best place on the screen is to place the sensor. You guys might not know this, but screens actually draw like this, not just like randomly, not all at once.
Yeah, dead center is fine. Ideally what it would be is like, say you're measuring a game. So if it's a first person shooter, then you would be putting it over the muzzle where the muzzle flash would be when you press the button.
So why don't we go with my personal favorite? We'll go with that CSGO.
Well, you're missing a step.
Oh, I see.
There was another cable in that box.
Yeah.
And it's still in there.
Oh yeah, wait, what's this for?
That plugs into the light sensor. Well, let's fire up the program first. That would be on the desktop. It's just in a folder called LDAT.
LDAT.
Oh yeah, it can measure audio as well. It's got a little 3.5 millimeter audio jack in there, so it can measure audio latency. In theory, you could measure any audio latency with that, like not even a computer, like a TV or something. So yeah, if you keep it in free running mode, then as you move that around, there you go. See, there was a little luminance change.
Whoa, look at that.
So if you put a brighter window over that or some kind of anything at all really. Yeah, like Task Manager, there you go.
Whoa, cool.
Yeah, so you can actually set the activation point for what luminance it should like pick up on. And yeah, it'll just do it. It's super fast sensor.
That's cool.
You can also add the mouse button as well with that second option so that it actually will detect when you click the mouse. This mode is mostly useful for setting things up the first time, and that histogram is what you get after you get the latency calculation.
Right.
Now, if you wanted to get something that's actually a latency calculation, put the window for LDAT in front of the sensor. Now click on the window, like somewhere other than a control.
Oh, cool.
Yeah, so you can just do that. It'll pick it up, how long it took for it to change. So what it's doing is it's actually sending the pulse to make the click down the cable that's connected to the mouse. It's not actually like using Windows or anything else to make the click. It's all in the hardware. So you don't even have to have this software running on this computer.
Not only does this automate the process and make it so that we can run these tests without a secondary PC or like camera capture setup, it's gonna save so much time, it even exports in CSV form, which we can then import into Excel and turn into nice little charts for you guys. But it doesn't tell us what is contributing to the overall input lag, it just tells us the total. So what we're measuring here is everything. Debounce, USB polling rate, operating system processing delay, driver processing delay, game engine processing delay, render to display delay, and then finally, of course, the pixel response time of our display. Which isn't to say, though, that it's useless, because if we've got this data, it means that we can change other variables one at a time and just see if the overall delay gets better. But it's got Nvidia right on the box. Can we trust it?
Yeah, I mean, it's just a mouse with wires coming out of the button that goes into the sensor. You don't even have to plug it into the same computer. It has nothing to do with Nvidia, so yeah, I don't see any reason why not.
Cool. All right, how about this other tool? This is the PCAT, or Power Capture Analysis Tool. You can tell these are named by the engineers, right? This is probably the most interesting thing I've seen in a long time when it comes to measuring graphics cards. Tools to accurately measure power consumption are not easily accessible, being either very expensive or very rare, or even worse, both. Methods we've used in the past, such as kilowatts, don't accurately measure power draw because power supply inefficiencies can creep in, to say nothing of the rest of the system's power consumption during the test. Even worse are the software-derived methods you might use at home because A, each vendor has a different idea of how to measure total board power, and B, you're counting on them to report it correctly. Never go up against a Sicilian when death is on the line! Which brings us then to these two PCBs. One with a PCI Express connector and card edge, and another with a whole whack ton of PCI Express power connectors. As you guys might have guessed, these allow us to measure the power flowing through each of these connectors. That is, both from the power supply cables that come into the graphics card and through the motherboard itself with up to 3 8-pin PCI Express 12-volt cables. Now on this puppy right here, we've got a removable OLED display that takes both the feed from the PCI Express board and the power interposers and spits out statistics and the current power draw. Nvidia claims it's within 0.25% of their oscilloscopes as far as accuracy goes. So with this, we can accurately measure what the real world power draw is for any PCI Express card actually, not just a graphics card. Let's go ahead and try it out here. This is one of those things that as a manufacturer, you have to have the absolute utmost confidence in your products in order to produce, because it's the kind of thing that obviously both AMD and Nvidia have had internally for years. But if you go ahead and you make all these tools available to, every Yahoo, hardware reviewer out there, then not just today, but for years, forever to come, they're gonna have the means to hold you accountable for your crappy products. So you basically have to think, not only do I have the best product today, but I'm gonna have the best product forever, and I want everyone to know about it, to produce tools like this and send them out. Because I've asked for years, like, you guys obviously have all these measurement tools, why don't you just provide them to us, because you have them anyway? And the answer is always like, let me get back to you, And yet, here we are. This is freaking awesome. How replaceable is this, Anthony? Is this just something NVIDIA is gonna sell in their web store, or like, is it reviewers only, or?
For now, it's a reviewers only kind of thing. It's just something that they've kind of built upon out of their lab. That's why you see the 3D printed components. Yeah. But they haven't ruled out selling it to consumers if there's enough demand for it. So maybe let them know down in the comments if you want to see that. Just make sure that they're on the input side versus the other output side, and there's a wire on each end.
All right, so Swifty Swamp. Let's just put that puppy, I don't know, like, brilliant. So they include up to a triple slot of little doodad-a-majigs that you can screw in here to your case so you can actually mount it securely.
Apparently it's a standard item for McMaster Car. You can actually just order them yourself if you need a different threading for your screws.
Oh, okay. Well,
which I think may actually be necessary in our case.
All right, we're going straight YOLO here, boys. Oh yeah, no problem. Piece of cake. Oh, the display's upside down.
This is why we didn't give Linus the tools.
Okay, here we go. Total power, 14 watts right now. Dang. Oh, I should plug in an HDMI cable.
Yeah, power usage probably go up a little bit with the HDMI cable in.
Ah!
The good news is the HDMI cable should anchor it to the back of the case here, so.
That's not a good solution. What do you work at Linus Tech Tips or something? What's wrong with you?
Listen, we deal in jank around here, right?
Of course you're not stuck just looking at this little tiny display down here. As freaking cool as that is, there's an accompanying PCAT Utility V1.1 that, like the LDAT one, can log to CSV files and additionally provide real-time power graphs. Look at this, not just total, but on a per source basis. So on our 2 8-pins here, you can see we're doing somewhere in the neighborhood of 4 watts or so. And then, where is it? Yep, 12 volt PCI Express, so that's coming through the slot. We're doing about 4 or 5 watts, so it's actually equally balanced across all of them. So then I can just fire up FurMark, right?
Yeah, and if you wanted to have all of those different metrics on the graph, there was actually checkboxes down at the bottom right there, and it'll just throw them on there for you.
Even just the Windows hardware GPU acceleration of the UI will give you these little spikes when you do stuff. Like watch, I'm gonna launch FurMark and it's be like, oh, 40 watts, hey, we gotta draw this window. Hey, okay, everybody calm down now. Hey, 250 watts. And I guess we can believe it because that's about what we would expect out of a board like this. And I mean, this is just power wires. Like it would have no way whatsoever of knowing if we have a Radeon or a GeForce or a Intel, dun, dun, dun. Not yet, but later, at some point.
Yeah, it's completely agnostic. As far as it's concerned, it can just measure power from whatever source. Doesn't matter if it's a graphics card or a sound card or a network card. You can just figure out what the power draw is.
We are gonna be able to do the coolest power draw charts for you guys. And it gets even better because finally both of these tools integrate into FrameView 1.1 to show latency and frames dropped by the display and power statistics from PCAT. Now that the overlay has Vulkan support, plus we've got integration of these other tools, there's actually very little that we wish that it did that it doesn't already. DirectX 9 and 10 overlay next, please, and thank you. Let's go ahead and take a crack at this. Campaign. So we've jumped to 4K and we're gonna see how this puppy performs here. How much power it draws. We're gonna know for sure. Pew, 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 pew. Broken arm, thing in your mouth, boom, broken head. Bow, 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 bow. You fell off a cliff, haha, take that. Oh, that guy threw a thing at me, don't do that. Anyway, that's not the point today. The point is, we are sucking back around 250 water-roonies with this thing. Oh wow, it's got the little display on it. I don't even have to alt tab out, I can see it right there. I love this. This is freaking cool. And I'm sure that if the price is reasonable, a lot of enthusiasts are gonna wanna get their hands on these things. Come on, Nvidia, put it on the store. Today's video is brought to you by the Drop Objective 2 headphone amplifier, AKA the O2 amp. This amp was designed and created with the feedback from over 500 Drop members on what they wanted and serves as an ideal baseline reference amplifier, powering everything from in-ear monitors to HD 800s. You can adjust the input, output, and power arrangements in 2 different gains, medium and standard, and it delivers big, clear, and accurate sound. Check it out at the link down below. Okay. What are we thinking for thumbnail?